the greater bird of paradise. That was the bigger one that was jumping around on top of the tree canopy. Females from that species are attracted to the dance that those males do. So if a greater bird of paradise, a female, saw a Parodia male dancing on the ground, and it was doing this little head bob dance, saying, "Hey, what's up? How you doing?" She might say, "I don't want anything to do with you. You look crazy. I'm just going to keep on going, and I'm going to try and find my male counterpart of my greater bird of paradise, my same species." Because exactly. So there's also, you mentioned earlier that there are more like cellular level mechanisms, and this is a gametic barrier, where either some biochemical process or size differences in the gametes don't actually allow the sperm and egg to come together and create a zygote. There's also post-zygotic forms of isolation, and one that we think of, or one that we can think of, is hybrid viability, where organisms come together, they mate, they form a zygote. However, something goes wrong and the pregnancy gets terminated. There's also hybrid sterility, where organisms come together, they mate, they produce a zygote, and an offspring is born. However, the offspring is sterile, and it can't have offspring of its own. And so we want to think about this as an evolutionary dead end. Question?
In the case of hybrid sterility, would you consider the hybrid to still be its own species?
That's a really great question, and I'm going to flip that around and ask the same thing to you later on. Okay? So one example that we can see, it's pretty common, is when we bring together organisms like horses and donkeys. When we breed them together, we create a sterile organism, which we refer to as a mule or a hinny. So new species originate after extended periods of time. Mutations accumulate, allowing certain individuals to become more fit under certain circumstances. So for instance, if a geographic barrier crops up, like a new river forming mountain range or a desert, this may divide species. And over long periods of time, these reproductive isolating mechanisms may cause them to diverge.
Could you explain to me what mutations have to do with the geographic barrier?
With the geographic barrier?
So why do mutations matter if we're talking about like a river?
Okay, so mutations coming up essentially divide species over long periods of time. So we can come up with examples like behavior. If a river pops up, organisms on one half of the river might do a dance to attract their mate that looks very different from the organisms on the other side of the river. So that would be one example of how behavioral prezygotic isolation mechanism can drive speciation. And these mechanisms are supported by cases where we actually see intermediate stages. And it's especially revealing when we have incomplete speciation occurring. So we're actually, yes? Oh, it's great. Go ahead, ask. Say that one more time. Yes. So we're actually going to do a small case study today, where we're going to talk about these really unique circumstances that happen. They're called ring species. They rely on these geographic barriers that divide species apart from one another. So essentially you have a population that may start up north, and they're able to migrate south. Their range is able to expand over long periods of time. When that happens, some organisms may choose to go west of the mountain range, or the river, or the desert, or whatever geographic barrier we're talking about, where some go east. Over long periods of time, their range might keep expanding, and then they come back together. And so we can see two things happen. One, they come back together, and they're able to breed and produce offspring, so they didn't actually speciate into two different species. However, other times we can see that the opposite happens. When they come back together, the individuals on the other end can't interbreed, and so we can witness speciation occurring. And we actually have this pretty close to us. Along the west coast of the US, we have a species of salamander called Incentina stolzii, or more commonly referred to as Incentina. And their range goes all the way up from Oregon, Washington, down through California, and they have this divide, this geographic barrier in the Central Valley. Here it's almost like a desert, or it is a desert, and it's much too hot and dry for salamanders to live. And we have a great example of how this geographic barrier has forced these organisms to split apart from one another. And we can see that they also look very, very different depending on where they are on the west coast. So up north we have Oregonensis, we also have Picta, and so on and so forth. And if you were to put this individual close to this one, they can actually reproduce and create offspring. And the same goes for Picta and Xanthoptica. But the thing that I want to ask you to do today is, let's imagine you were out hiking and you think you found was a new species of salamander. So you were hiking in this area right here. While hiking, you came across a new salamander species, or what you think is a new salamander species, but you remember learning in this class that they have different color forms or different phases of how they look. So in small groups, I want you to try and design an experiment to test if some pre-zygotic isolation mechanism is actually occurring. Great. So you're bringing the organisms together and you're doing something to see if they can actually form a zygote. So wonderful. Did anybody come up with anything else? Yeah.
Genetically profile them to see how much of DNA from each species each one contains, to see if they have been interbreeding.
Okay, yeah, so you can see if there's some sort of genetic mixing going on there. That would be a great test if you can do. Yes?
Observe what chances they are yearly.
Yeah, great. So you can look at their temporal reproductive habits that they have and see if they're reproducing at the same time of the year. Those are all great answers. So just because we're running out of time, we're not going to do the second half of our experiment. But I want to just note that there are some major drawbacks to the biological species concept. And I want to see if anybody can come up with an example. And to start out, just think really small.
Well, biological species concept says that there are species that they can make, but there's still hundreds of thousands of millions of species that have been extinct. It's about like they died, we don't know where they fit. Logically, that pretty much know where all the other species still fit.
Yeah, great. So species are extinct. We can't tell if they're able to mate. Yeah. So subspecies is kind of a controversial topic. Actually, in this example, people are saying that all of these different salamanders that look different are subspecies. But for this, what I was hoping someone would say is microbes. So microscopic organisms typically reproduce asexually, and so we can't fit these into the biological species concept. So if we think a little bit larger, what's another organism that you guys have learned about in this class that Dr. Van Nolly talked about that isn't a microbe that doesn't reproduce sexually? So yeah, right here. We have whiptail lizards. So these lizards are unisexual. They're all females. They don't need males to reproduce. We also have things like fossils or extinct organisms, like you mentioned. So maybe organisms whose geographic ranges don't overlap. So maybe you have organisms on different continents. And then we also have viruses. Viruses are really controversial about if they're actually a living organism. You have a question? No, so for these whiptail lizards, they cannot mate with other species of whiptail lizards in the area. So these ones are distinct. They can't form, they have the pre-zygotic isolation mechanism. They might. Depends. So hold on, before you go, I have one last question for you that will really help stimulate your thinking for next class period. So for anyone who's ever seen Napoleon Dynamite, we have lions and tigers. And in institutions like zoos, we're able to bring these together and they can mate and produce offspring. However, they live in very different parts of the world. And so you get something that is kind of mythical, if you want to think about it that way. We create a liger. And so the last thing that I want you to do today, to start to get you thinking about phylogenies, if you were to mate a lion and a tiger together, where would you put it in a phylogeny? Would it be a new species? Would it be a lion, or would it be a tiger? And so our last learning catalytic of the day, before we go, is on this phylogeny. We have a lion right here, and we have a tiger right here. I want you to fit in a liger into this phylogeny. And all you have to do is touch on the screen where you think it will go.